2022. So we are very happy to welcome all of you to this function. This webinar, our main program, has become our second function after the essay competition, which has been conducted just yesterday. Yesterday, there was around 25 students have participated in the essay competition, and we had a good competition. And after that, now we are on our main program, a webinar, which includes the message on Inspire Sat and the science day talk by Dr. Ravi Varma and students' presentation. The students who have been selected for ATL Space Challenge conducted by ISRO. So we are very happy to welcome all students and all invited respected persons. So we are very happy for that. UL Space Club has been conducting online webinars since May 2020 when the COVID pandemic era started. We could successfully complete 44 webinar sessions as a part of our national webinar series, and we were happy to conduct, and we could successfully complete many other sessions on such special occasions like Science Day, Kalam Memorial Day, World Space Week celebration, days like that. So we are very happy to host this function also. February 28th is celebrated as National Science Day to mark the invention of Raman effect, which is one of the best invention in the last century, which was done by Sir C.V. Raman, the great Indian scientist. So very happy to host such a function on this memorable day. And we have to announce that UL Space Club has made another work related to this Science Day to remember C.V. Raman, who invented the Raman effect. So we made a collage-like thing, a presentation to show the lifeline of C.V. Raman. The life incidents happened in his life. So we had made a presentation to circulate it through our social media channels. So we will post it on after this program. So it will be available to all followers of UL Space Club. I am very happy to announce that also. And today we have a wonderful session because we have two experts to talk on various topics, and we are having an expert talk on a message on Inspire Sat. Inspire Sat is a student satellite project which has been done at IAST, Indian Institute of Space Science and Technology, Trivandrum. So we are very happy to have Ravi and KrishnaMurthy are here because all of us were really excited to know about student satellite projects, and we since the first camp of UL Space Club, we were discussing about it. So we are very excited to hear from him. And also we have Dr. Ravi Varma, who has been supporting us for all programs of UL Space Club. So we are very excited to hear from him also. He'll deliver a Science Day talk, and we have a few other programs related to that. And so after that, we will have the student presentation, like I said. Before going to schedule as a part of the introduction, I just have to mention there will be a few instructions for student participants. All of you are requested to switch off your mic and camera throughout the webinar, unless you are asked to switch on it. When you are asking a question, or if you want to ask something, if you are permitted, you can switch on your mic and camera. Otherwise, please keep it switch off. Otherwise, it will make an interruption to other participants when they are listening to the presentation by our speakers and the students. So please don't try to do that. And please don't try to share your screen. There might be presentations by our speaker or some presentation by UL Space Club. So please don't try to share your screen. So it will be an interruption to our live streaming, which has been already started in the UL Space Club webinar YouTube channel. So please don't try to do that. We will have a chat window here. You can ask your question in the chat window. We will select the question for to the interactive session if the time is allowing us to do that. Otherwise, we will answer all questions after this webinar. All of you will get the answers. So you can type your questions in the chat window. Use the chat window in a good way. All unnecessary talks in the chat window is strictly prohibited by the decision taken by UL Space Club Program Coordination Committee. So please don't try to do that. These are the instructions for the student participants, and we will have a wonderful session. Let's make this Science Day as a memorable one. So let me move on to Shadil sir to give a detailed introduction about the experts and our all programs. Shadil sir.
Okay, thank you, Varun. A warm good evening to all. And we all are sitting here under an umbrella of UL Space Club to celebrate National Science Day this evening. And UL Space Club is functioning at Calicut for the past 5 years and under the leadership of EK Kuttisar and the ULCCS, the cooperative sector, largest infrastructure cooperative movement in India also. We are so proud to be part of that, and we are nurturing our students to the science environment. Actually, we are creating an environment for the STEM basis activities are going on here, and we are getting overwhelming support from all the scientific community all over India, because all these are things are blessed with the veterans of ISRO and other scientific organizations and the young scientists also supporting us, and we are in limelight. We are glad to say that, we are proudly say that we are in limelight in the field of science and education now. So we so proud to be under umbrella of these things. In this moment, we are remembering the honorable uh, Dr. Chandrasekharan Venkataraman in this evening, because he brought that Nobel Prize to India years back, even before our independence. And National Council for Science, Technology and Communication is celebrating this day. And this year's theme is integrating science for sustainable development. That's the theme, and that's why interdisciplinary approach is yet to be reached by these scientific communities. And today we are honoring a great scientist. He's from Calicut and he's from our land. Is Dr. M.K. Varma is recently honored by a great award from Dr. Vasudev Award from Kerala State's Science Council Technology and Environment, and it was awarded by Chief Minister of Kerala, Mr. Pinarayi Vijayan, and we have a great scientist from ISRO. That's the honor of our day. That is Dr. YVN Krishnamurthy. He is the registrar, professor and registrar of Indian Institute of Space Science and Technology, IAST Trivandrum. And along with that, we have some few three student scientists who are selected for the ATL Space Challenge from GHSS Nadonu, Diyadi Darshan Karat, Lavanya, and Srilashmi. They have made an antenna to detect the solar radiations, and they have started a solar detecting center at their schools with the support of the teachers. So it's a great step or a huge leap by these students, and that the environment we have created here. And we expect few more little scientists from our school campus, college campus, and all these areas. And we are conducting a lot of programs related with this in National Science Day, quiz competition, essay competitions, and all these things. We are getting blessings and support from our veterans from ISRO, PJ Bhatt sir, Sundaramurthy sir, and Dr. N. Sundarajan sir. And let me invite all of you to these occasions, and I invite all the dignitaries, all the chief guests, and all the students and teachers and common people who gathered here to celebrate the great day of India in the field of science, because science make us or made our life so easy and comfortable, and we are with scientific temperament. And more than that, all most of these students are uh, so eagerly want to become some scientist, and they want to enter the career and other educational avenues in the field of science and technology. And before we are and I invite all these dignitaries once again. And before we go into our official program, let me introduce our chief guests for there may be some newcomers in our gatherings for them. And for the forum, I am presenting Dr. YVN Krishnamurthy is a professor and registrar of Indian Institute of Space Science and Technology, IST Trivandrum. He's a great scientist from ISRO, and he has significantly contributed during the last 4 decades in promoting remote sensing and allied geographical technologies That's navigation, GIS, communication, and resource management, and extending their use at grassroots level. His contribution in developing innovative methodologies in integrating geospatial inputs into conventional methods by greatly facilitating the ultimate assimilation of such inputs in the planning, implementation of development programs by concerned with technocrats, bureaucrats, and NGOs, even user community. As a scientific secretary, ISRO has spearheaded major policy level functions in planning ISRO's programs and evolving national policies for space technology development and developing public-private partnership for ISRO programs, international cooperation, human resource management, leadership development in and development ISRO, and enabling public outreach of Indian space. And he was the director of National Remote Sensing Center (NRSC), was responsible for Earth observation satellite data acquisition. And Krishnamurthy sir developed a lot of systems, not only for the scientists, even for the farmers of India to analyze. That's why that resulted in the form of under Pradhan Mantri Krishi Sanjay Yojana, and the GIS implementation was there in Mahatma Gandhi National Rural Employment Guarantee Program and crop insurance programs. A lot of activities are done under the data and the technology produced by or supported or evolved by the great scientists of India. And we are so proud to have Dr. Y.V. and Krishnamurthy sir in this occasion as a scientist of India, and now he is nurturing the future of India from this great institution, Indian Institute of Space Technology, Trivandrum. And in addition to that, we could proudly say that even now, he is doing well because he has done a lot of work as payloads like Ares in PSLV stage 4 and all these things. There is a history and there is a lot of experience he's part. But that same recently, the 14th of this February, a new things have happened from IAST under his guidance. A small satellite, Inspire Sat, totally designed and fabricated, tested and ready for, and it was launched in PSLV C52. Now it's in the orbit, and I think Krishnamurthy sir is so happy to be that it's functioning very smoothly as a proud of this Indian Space Research Organization and for the IAST, and that's a result, it's a reflection that this great scientist is still supporting this nation, is working for the nation, and still we are so happy that he's supporting the UL Space Club for the past few years. So we happily and proudly welcome our honorable guest YVN Krishnamurthy sir to this occasion. Welcome, sir. And next we have Dr. Professor Ravi Varma MK from NIT Calicut. He's a person from Calicut, and I could proudly say that he is an alumnus of Government Boys Higher Secondary School Balisheri, and I was also lucky to be with him 2 years or 3 years back as a junior with him, and we are the whole land is now is proud of him, and we are celebrating his recognition by state of Kerala, and he is recognized by the state of Kerala on his prestigious project as a multi-wavelength integrating nephelometer for characterizing topography tropospheric aerosol, but because this scientist is so concerned about the global warming, and this project is concerned with the climatic effect, global warming, and its effect on day-to-day life. Tiny particles in the atmosphere, that's aerosols, are emitted by both natural and anthropogenic sources. The amount of particular matter and kind of present in the troposphere was significant impact on air pollution and human health, visibility, and climate. Apart from greenhouse gases, aerosols affect climate directly by scattering and absorbing solar radiation, thereby modifying the energy from the sun available and subsetting temperature equilibrium of state of earth. That's why we are so uh, worried about the 1.5 degree hype, and we are worrying whether we could survive on this land after 20 or 30 years, because we are so conscious about the younger generation. That's why he has tested his experiment. The project was developed in a new climate monitoring instrument that were demonstrated in the field of observation Yangtze River Delta in China. Most important of all, technology of newly developed instrument, visible integrating nephelometer, was transformed to Optine Solution Private Limited, a spin-off startup from Incubator Technology Business Incubator (NITC) under the NIT scheme for transfer. That this reflects this professor is not only involved in the development of science, at the same time he is nurturing the industry also. There is an incubation center at NIT. He's a founder leader of that incubation center TBI, and he's promoting entrepreneurship along with these academics. And Dr. Ravi Varma, a native of Balisheri, Panangad, a physicist working in applied optics and instrumentation of materials characterization, health diagnostics, air pollution monitoring, and climatic applications. Monitoring of greenhouse gas emissions as methane and carbon dioxide. All these are considering these things. And he is a graduated from Government Arts Science College, Calicut, MSc Physics from University of Hyderabad, and he's an atmospheric science postgraduate from McGill University, Montreal, Canada, and PhD in atmospheric science from Desert Research Institute, Department of Physics, University of Nevada, USA. He's serving as a faculty of Department of Physics, NITC, from 2009 onwards. And now he is in charge of startup ecosystem in NIT Kozhikode and Northern Kerala. He is Secretary of Technical Business Incubation Center (TPI) in NIT and an active promoter of Young Innovators Program (YAP) of Government of Kerala. Today itself, the school children in Kerala, all the college students are joining that Young Innovators Program. That's a new idea competitions. Most of the students are actively participating, and we are feeling that experience. Is the advisor to Education Skill Development Program under the District Administration Kozhikode, and I am also lucky to become a coordinator of this project, and he's guided that project well and advised that. And he's the Institute Innovation Council, NIT Kozhikode, has secured 5-star rating under his guidance, and he's also bearing the charge of chairman Center for International Relations and Foreign Languages in NIT Calicut. Now he's connecting language with technology, and he's exploring all aspects for the development of the technocrats and the students and even for the common people. And he's worrying about the things to provide some employment to the rural people, and he's decided to start some startups and ecosystems at Panangad Gram Panchayat, his native place. So we proudly welcome our Honorable Dr. M.K. Varma to the forum on this occasion. Welcome, sir. Then I welcome Dr. E.K. Kuti, former director, Kuti sir. Our Kuti sir is among the Kutis in Malayalam and children, and he's enjoying his retirement life, and still he's enjoying is the light of this all these organization and all these endeavors. And I welcome our Honorable E.K. Kuti sir to this forum. Once again, welcome, sir. Then I invite Dr. S. Rangarajan, sir, former director, MCF Hassan, and is continuously supporting our programs, Dr. S. Rangarajan, sir. And PJ Bhatt, sir, is there. He was with us even in offline programs in Calicut University, NIT, and all the camps. And Corona is only things that's keeping away. And I welcome PJ Bhatt, sir, to this forum. Once again, we have Padmanabhan, sir. We have Sundaramurthy sir and Sundararajan sir. He's continuously supporting our students and directly contacting our students, and he's providing a lot of eminent scientists to this forum to contributing to our students. So I welcome Sundarajan sir, and I welcome Dr. Nikhil Vogel. He's joining from Germany, Hanover, Germany, from Max Planck Institute. And we could proudly say that he's a student of Dr. M.K. Ravi Varma from NIT Kozhikode, and now he's working on the gravitational forces and science, and we have a great future with him. And I invite Dr. Nikhil Mukund once again to this forum, and I invite all the dignitaries, all the veteran scientists, honorable scientists, teachers, students to this forum, and I request Honorable Kuti sir to chair this forum formally. Welcome, sir.
Thanks, Shajil Mash. You have made a very elaborate introduction, and nicely introduced our chief guest and guest of honor and all the persons, veterans and our guest experts and various scientists and seniors who have been guiding us, our students, in all our endeavors, including the Science Day of today. Science Day goes without saying, without giving much explanation to it. Already it is done by both Varun and Shajil Marsh. But one thing I would like to say is that Dr. C.V. Raman kept the scientific spirit burning in the minds of youngsters even after 50 years of his departure from this world. And this day is very popularly celebrated all over the country, and today several functions are happening. So, so this day is so dear to us. And last year, Nikhil Vogel, who is already here, Dr. Vogel, was the person who was the man of the function last year on this day here. And we are able to attract various kinds of experts and well-known personalities in India and abroad to be interacting with our students. That is our big blessing. So I don't want to proceed much on that. Our chief guest, Dr. Y.V.N. KrishnaMurthy, our guest of honor, Dr. Ravi Varma, our expert panel, expert judges, P.J. Bhatt and Sundararajan, T.K. Sundaramurthy, the students who won the ATL Space Challenge, Niyati, Lavanya, Sri Lakshmi. I would like to mention here that I was with them yesterday in the school where there was a function to honor them, and I have been very fortunate to meet them personally there. Before that, when they got this award, this ATL Space Challenge, I spoke to each one of them on telephone, and I was so happy to see that their excitement, interest, and their knowledge in the area and their thinking process is something very, very ideal to make them as scientists. So I'm very, very happy to be in the midst of all of them. And importantly, lot of my friends and colleagues and our usual people are all here in this. And when Shajil Marsh was talking about Y.V. and KrishnaMurthy, I worked with him in ISRO for quite long. Ever since he joined, I have known him, and he has been an excellent leader and made, very, very outstanding contributions in various areas. And I am also fortunate to know personally Dr. Ravi Varma, who is our whom we are honoring today. And he has been, I have visited the NIT a few times, and I have met him there, and he has treated us very well and our students. And even in the district administration program, which Shajil Marsh said, I have been working with him for skill development and inspiring the students. So it's a very, very nice day for all of us, and I wish the very best for the students. And already time is late. Let us move on. So very, very happy Science Day and a very nice day indeed. Thank you very much.
Thank you, Kutti sir. And I invite Dr. Y.V.N. KrishnaMurthy sir, and he will speak on the Inspire side. Along with, I will honor our guest of Dr. Ravi Varma by reading a citation. Welcome, sir.
Thank you, Dr. Sajil. I hope my voice is clear, sir.
Yes, sir. Yes, sir. It's clear.
Yeah. And also for UL Space Club with all youngsters and guided by our Kutti sir, and also a lot of seniors who are there, Rangarajan Saab. In fact, it's a pleasure for me to be associated here. I think next time you should not introduce me, because I am part and parcel of yours for a very long time. Okay. So, and I'm doing now on behalf of UL Space Club. And it's really nice to hear, especially like other day, our Varun called me for certain payloads development, etc. So it's nice the student directly it's an opportunity for them to call and then find out some things, how to make payloads, etc. This is really great. That's a great opportunity which you are creating under the UL Space Club. And keep up the same team spirit. And Rangarajan sir and Bhatt and Shivaraman and so many people I'm able to see. Today I have my other colleague, Dr. CBS Dutt, who is also always a good critic in science, that he always used to push us. No, you are doing something, but you're not understanding the science behind it, okay? And on remembering our Sir C.V. Raman sir on this day, and whatever the impact they have given us globally in understanding science and tools and whatever the technologies which you're trying to develop from understanding the science, yes. And thanks for the opportunity given to me, because I'm here in IAST besides the registrar and senior professor to take research to higher levels, facilitating my colleagues and also bringing them together as a team, because anything to deliver, we need to have a teamwork, and from different disciplines, how we come in making payloads, first sensors, then put the payloads, and then make as a satellite. And we have a vibrant small satellite program. We have a facility called S-Space, I'll briefly mention. And we need to keep certain equipments for design to fabrication to testing, which is very important. And then when you have international collaboration, we also have to be equal with others in not only understanding, but also delivering things what we mentioned. So I will share a few slides with your permission, so that it will be nice to, and the satellite is quite healthy. And and that's where we stand, and we are all happy, not only here, across the globe now IAST is known because more than 10,000 packets are being downloaded by our young friends everywhere. Okay, I'll get into it. Yes, sir. You are able to see the screen, sir?
Yes, sir. It's okay, sir. It's coming. It's very clear. It's very clear, sir.
Okay. Now, this is what for InspireSat 1 evolution, because to get into hand-holding with someone else, others also look at that. We also have some specialization, and we also have some things the others can learn. It is not that a one-way traffic when we have a collaboration. So we have a small spacecraft systems and payload center called S-Space. Last time also I mentioned about Ares payload is also carried out under this domain. That's what my entry here in Trivandrum in the first 6 months that has gone on PS4 stage, and it's for a very successful mission in understanding certain parameters of ionosphere. This is what the S-Space does. We look at low cost and low risk platform in which we can test and also validate some of the instruments, and also interaction with the experts. That is a facility for all the students to have, and the capacity building in whatever we have learned, how do we share with others, and mechanism. And here I would like to tell the students are mostly the third year undergraduate students. Okay, that's where they start the projects. And this, whatever has been realized, is by 3 batches of these such students. That means in 3 academic years, what we are looking at. So if you have an overall design and understanding and a platform and instrumentation which they need to do things, it's possible to do. So always we think that the same set of people till the end of the project should be available. It is not so. There are principal investigators. One is Dr. Pridarshanam, who is the principal investigator from IAST side. He's a professor here. And also there's Professor Amar Chandran. He is from University of Colorado. And we also have an interaction, collaboration with NCU Taiwan and NTU Singapore. So these are 4 institutes which came together. There are a few things which we did by ourselves, and then which we shared the knowledge with other missions, which I'll show you in the next few slides. Basically, as I already mentioned, this is a low-cost risk platform. So payloads, what needs to be experimented instead of going for a larger satellite, how to make it initially, how to identify the requirements, the design, and fabricate these payloads to see for in the advances of space research.
Excuse me, sir. One suggestion, sir. If it is made it full screen, F5, that would be better.
Yeah, you are able to see now the full
Yeah,
screen.
it's in the file mode. If it made the slideshow in full screen, that would be a better one, sir.
No, actually, that is what I was doing. Even in the morning, I had a problem.
Okay, sir. Okay, no problem, sir. At your convenience. Okay, sir. No problem.
Let me see in.
Okay, sir. Doesn't matter. At your convenience, it's better, sir.
No, it's actually morning I tried for this,
Okay.
and it was not working, especially in this platform.
No problem,
actually,
sir. No problem.
But then it is not coming for display. The other side.
Okay, sir.
It is visible and all that. The only thing, slightly small print. That's all. Otherwise, it's okay.
Yeah. Or else I will share.
No problem, sir. Carry on. No problem, sir.
The club
Carry on,
members,
sir.
so that because everything is coming, but
coming.
click on to that and then go into the other mode, you are not able to see.
Carry on, sir. Please carry on. Please carry on.
Okay. You are able to see, sir, the screen.
Yes, sir.
now?
Please proceed.
Yeah, but
Sir, you reduce the notes on the left side. Cut it out, sir.
fine. Okay.
Yeah.
Yes, sir. It's okay, sir.
Yeah. So this is basically the other which I was telling you is the collaboration and also the participation in planetary missions of ISRO. See, that's where what the requirements of ISRO or the need in looking at this low-cost platform and then also when we talk about low-cost platform, we are also looking at COTS components. So how do we harden them for space requirements? And then nurture an academic environment of innovation by space technology, by conducting some specific courses, workshops. In fact, you will be surprised in the second year students during this pandemic, first phase of the pandemic, they came out with 13 proposals of different payloads which can be made and launched. They all are unique. There are four students as a batch. They came out and each one is really unique by themselves in their thinking process. And I was really surprised the second year undergraduates are able to think at that level. So this is the potential what we have. So our job is to see how we can enable them with the thinking process. That's the most important thing. And some of our club members also, young boys and girls now also have joined undergraduate courses and they're also coming up and they have a lot of interest in making payloads per se. And other one, most important is the laboratory facilities establishing. That is one important. What is immediately needed and a priority basis, how do we make such? And also establishing incubating center. So we have also now in our facilities there. Now already one is giving output from our innovation and incubation center. And then three more are joining. The facilities already in place to use and put through. And also major industries also wants to incubate at IIST, giving certain facilities which can give opportunity for our students like L&T and all. And these are some of the missions which are the roadmap. So it is not just one, we need to have a longer run in which we have to look at. The next one which is on the pipeline is AHAN. That was initial spacecraft which is supposed to go from IIST. Total everything done from IIST itself, unlike InspireSat. And then there are other InspireSat missions which will be put through. But also docking and re-entry. These are the type of payloads which has been discussed at a certain level so that we can make astrobiology experiments too at a low cost. Because where we can afford to, but then hands-on in terms of telemetry, commanding the station or station keeping of the satellite, everything is done by the students themselves. So that makes us also highly motivated that youngsters are able to put through. These are different models of the satellite. So there's an InspireSat 4 and InspireSat 3 also are in the pipeline. So where we had to sign the MOUs, everything is going on. And there are a few requirements from ISRO which are there, which we are flying as a small satellites. So AHAN is like a CubeSat, and then multiples of CubeSat. This is what we frame. So the bus is very important, and which has been tested for another program along with Caltech and University of Surrey, where we made a modular docking system for space observations, like a telescope. But then we are also looking at future how solar energy from space. That is another mission where prototypes are being discussed. So that is where we need docking and re-entry. So whatever we do, it can be expanded into bigger ones. So that is where the entire process chain which we are putting from the technology front. But all our science payloads which are go on this. So we have various countries which have come forward for the InspireSat program, where the flags are represented here. So the 8 countries is part of it, and few of them are contributing for different satellites and for launch too. In fact, the InspireSat 2 was launched, and 3 from our SpaceX. And one of the InspireSat 2, they had a problem of data reception. In fact, the ground receiving station of IAST, which is established by the time and was functional, has supported them in the initial days for telemetry and data reception purpose. So, being collaborators, we have a shoulder to hold or stay when we have certain requirements. So, this is the team, InspireSat team of various participants from different parts of the globe who came together. That means use small satellites to understand space science, and then that input can also be a very valuable input for the major space-faring nations for making space exploration. So this is where it stands. That's all the total objective of it. By student satellites, how they can solve some science questions, and how it can be for the major missions, which can be as the space agencies can take it up. So this InspireSat 1 basically is around 8.3 kgs, a very small satellite. And then this, it's all totally, as I told you, autonomous from these collaborating institutions. And the IAST scored contribution, because they're all everywhere, but mainly which is depend upon IAST is on electric power system, then onboard computer, then flight software, and ground station telemetry and telecommand operations. Most of these things, everything was done indigenously. All our colleagues, including the ground station, you will be surprised, including the 4.5 meter antenna and all. Wherever they had them spares, they brought it from other centers, assembled everything, and they have wetted their hands on top of it. I'll show you the team members who are also a part of this. So this is the satellite, and this is the solar panels which has to put through. This is in the test condition in IAST lab itself. It was there for quite some time before the launch. And then the main objectives of it is observe the occurrence rates and characteristics of plasma irregularities at low and mid latitudes, and also the spatial and temporal variations of the midnight temperature maximum, and ion density and drift velocity in the nighttime ionosphere. So these are the 3 major objectives for which the instruments have been made. So as you are all aware, there is a plasma irregularity climatology. So how this irregularity frequency along the magnetic equator, and this is where one of the major objective of this satellite. So the data is very valuable. So this is where one of the important message I would like to tell all the youngsters. We have many satellites launched. If you ask me how much of the data really we used, it's not really encouraging. Let me be very frank. So this is where we need to pull up. Using the data, analysis of it is also as important as making a satellite. In fact, it's much more important than making a satellite and flying through. Yes, we all have a lot of applause when we launch. But after the launch, the real challenge starts in terms of station keeping, understanding its payloads better, and then the data which comes in, how do we process, and how do you take in the process chain, and how do we enthuse people to join in the science groups to analyze the data per se. This is the midnight temperature maximum. This is another objective which has to be addressed. So there are a few models which accurately capture the MTM, but then this is where it is going to make a lot of difference, the data what we are going to acquire from InspireSat 1. And these are the two payloads. One is the compact ionosphere probe, and other one is dual aperture X-ray solar spectrometer. So these are all to better to understand the ionospheric dynamics and the ion temperature, composition, density, and velocity by compact ionosphere probe. And here basically is to understand the sun's coronal heating process by measuring soft X-ray spectrum of the sun. In fact, this payload has been switched on today. We've commanded to switch on, so it has collected some data. But when it comes to our view of visibility, we had a download and we'll try to analyze the data and its quality. So on a science day, that has been switched on in the morning today. And these are the team, because from each of the institutions, we have for InspireSat-1 from Colorado University and Singapore and Taiwan and National Central University. And here, basically, besides the two professors we are seeing here, Dr. Priyadarsham and Dr. Ravindranath, we have a host of all our students only. And some of them are joined, like Anant and all, they have joined ISRO already. And there are someone who is doing the project's final. And then one more batch earlier were also. So the three batches who are there who worked on. And here, Joji John, okay, he's in the ground station in charge. He's a project fellow with us and highly knowledgeable. And in fact, the way he thinks is something amazing. The other day, 2 days back, when I went to lab late in the evening, literally he sleeps in the lab. And that is the type of interest he has. And he got many jobs of a higher salary, but he's still not leaving. Though I encourage him to find better opportunities. But since his interest in understanding technology and to convert them into certain instrumentation, is including drones and instrumentation on drones and spoofing mechanisms, and also the identifying targets. Amazing things he's able to do. And in fact, he got many prizes in the national level prizes for the work what he has done. In fact, this is his creation with the Professor Ravindranath. He did everything of this instruments, because when I joined, it was a small it's a rack with a small instrumentation, but today we have everything equipped. There is a 7.5 meter radar mesh reflector and UHF Yagi antenna is also there. And within 2 days, we also established one more antenna, what is required, because for certain questions, when we had in uplinking and downlinking, we had some doubts because there may be some interference when it's a low inclination angle for the satellite. So on the library where we have a highest this thing where there's no obstruction at all, and you will be surprised, in 2 days the entire antenna has been established, including the measurements, everything very perfectly, and it is on today. We are able to command from that antenna too. So this is where for youngsters what they need is they need an instrumentation, they need a lab, they need to to test, and then and someone to guide and do that. That's more than sufficient for them to think big and achieve anything which is complexities. But as when you tell a small satellite is equivalent to a large satellite. So we need to have all the clearances. In fact, the first thing when we had to get the satellite, because satellite is integrated in University of Colorado, that's where everyone went through, and our own students also were there, and everyone went through and did that. So how to write from customs clearance? Because this is worth the crores of rupees. So how do you project this, and how do you get? So everything was done very smoothly, and also all the tests, no bypassing is there. Everything has been taken care, and also the to put in the orbit, the PSLV also had a team, and for and Srd, they've given us excellent support for doing all the activities in time, and everything smooth. And then we have the COVID, and the right people who are supposed to go for integration, they got COVID just 1 week before, and they got negative. Then I had to get special permissions for them to go to Srd for integration, so that we are 100% sure. So everything cooperated. We have a system that means you need to have 14 days quarantine. Everything is there, but still there are several special permissions, and luckily everyone is safe. That's the most important part. And because of our students, no one got exposed for this thing. So there's some blessing somewhere. So everything's gone smooth. So this is how the data comes in terms of the downlink when you get the packet about the temperature and including a solar panel on the skin and panels per se, and what is it and how it is, what is expected versus what is desired. So all these things are updates which are put through. And today, in fact, some data has been received in Taiwan, okay, today morning. But we'll be getting this by evening today to our, which will be transferred. And subsequently, we'll also be commanding for the payload data. Or else today, all the telemetry is through UHF, where we are uplinking and downlinking satisfactorily. And if you can see, more than 10,000 packets have been received globally by the SADNOX community. So open decoder definition also provided for all the amateur community. So there's a lot of excitement in the people. And then, yes, you are known globally that there is something someone can do, such payloads and launch and see the data comes down. And that is where the recognition comes for the youngsters, and that makes them more. In fact, you should see the first uplink command, which has been done on the same day, on the 14th. We could do an uplink command, and that is what the test of the ground station, which has been established, and they were so happy. And this is of the InSpatSat ready for ready for launch, which is there. And this is where the flagging of by our director, but Chairman ISRO on virtually. He is interested because he was also, you're aware that he was also on additional charge as director IAST before becoming the chairman. And he was the first person to come immediately after joining to see the students. I will just show you a photograph of it. And VSSC has provided us the transportation, which is very stable to ensure the G levels to satellite to be going comfortably there and then putting through. And that all happened. And this is where in Shar and Rajarajan flagged off this from the lab where we had to test, integrate, and so that there's no interferences with everyone. And this is where it has been fitted onto the PSLV stage 4. And this is how with the heat shields, right? And you can see the payload located here. And this is the team. So all the students who went to these clean rooms, etc., they were so happy. And on SP Launchpad and the launch, you all witnessed this. And yeah, this is the international team, which is there at different places. So they also were part of it. And this is with our chairman, Sri Somnath. And this is the satellite, which was there for testing. Especially after satellite comes, we have to integrate with the ground station and simulate every test what is needed. So following all the protocols and the ground station, which is being established, the antenna. And this is where even Mr. Somnath have come there to see and ask questions and give all the necessary support. And few dignitaries who also visited this place that is on last Independence Day. So that is when the satellite has come. This is on the team working on it while integrating. And yeah, so this is a good success story in terms of collaborating. These are facilities. So this is where the small satellites will place. And this is all the things which are happening. So many parallelly now testing all the features which are going on parallelly now for other satellites which is put through. So in less time, everyone has understood what is a small satellite, and all the components of a major satellite are there in this in terms of power, telemetry, or telecommands or communication part of it, and data download which will happen, and how to position the payloads and orientation of the satellite. So everything is a perfect thing happening so far. So this is a 1 year life, which is the mission. I hope with all the efforts what the students made, this will definitely be a successful mission, and the data will be very valuable. And this is the strength lies now in analyzing the data. So the science team has been formed with SPL and PRL and other colleagues who are under the space science activities. So, and they'll be guiding the students do the analysis. You are aware we also have a dual degree colleagues for students who work on space science and space science related payload data. So they are being put on the task to take it further. So this is where I will stop sharing. So on a science day, it's really a nice thing to be a part of it. Yeah, and share the success. But then it's a good teamwork. It's not only from IIST, but also other resource centers who are also eager to help and try to understand also how this small satellite and its components really work. And yes, there is a lot of things to learn how to, because when station keeping is not an easy task, Rangarajan Saab and all are well aware. We had to be very careful in station keeping and record keeping. That also we are learning. Okay, whatever I learned visiting MCF or ISTRAC in my previous tenure, started keeping some kind of an arrangement and making professors understand, because academics is a different game altogether. Make them understand in the seriousness of the business. While something fails, what we should search for, where we should start. That is the thing which has to take place. So all youngsters here in the UL Space Club, you have a lot of opportunities. Since a specific place has been established now, your payloads, what you're discussing, you can now, the things of COVID also has become normal. Maybe you can visit and understand what are the things initially we need to understand if you want to make a payload. That's most important. Means identify the requirement and why we need to do this. Why not in a different way? That is the first starting which we need to question ourselves. Then everything flows. There are people and experts to help us out. Thank you, sir, for giving me this opportunity and also for subsequently to honor our guest of honor today. That's really nice. So I leave it to now Kuti Saab. If you ask me to start with Dr. Ravi Varma Saab, I will go ahead on that. It's up to you now. Yeah.
Okay, Shajil Marsh.
No, it's a great honor for me to do this function. Dr. Professor Ravi Varma, I just heard your introduction too. It's great, especially these are people like you are needed at this hour. What I see in IIST also, the core sciences, unless we understand the basic science, before you make an instrument, and this is what Professor Yuval Rao Saab always used to tell me. Okay, maybe for the last few days before his passing out, always, we have to understand the basic science, then the instrumentation. Or as most of the time we bring an instrumentation, we fly and then do certain things. So people like you, now Professor Ravi Varma, are the future. If you had to make indigenous payloads or instruments in our country, and already you're doing, and you're also encouraging the youngsters to put their own startup related. So on behalf of UL Space Club, I have the privilege to read out the citation to honor Professor M.K. Ravi Varma from NIT Calicut. On the eve of the National Science Day celebrations, the UL Space Club Kozhikode is extremely happy to honor Dr. M.K. Ravi Varma for his outstanding contributions in the areas of research, teaching, and education, while serving the National Institute of Technology, Calicut, as its professor, Department of Physics. Further, laurels are brought to him by bestowing the prestigious Dr. Vasudev Award 2021 of Kerala State Council for Science, Technology and Environment, which he received from Sri Pinarayi Vijayan, the Honorable Chief Minister of Kerala, in recognition of the excellent work he did on the project, a multi-wavelength integrating nephelometer for characterizing tropospheric aerosol. The project, which is concerned with the climate effect, global warming and its effects on the day-to-day life. As a physicist working in applied optics and instrumentation for materials characterization, health diagnostics, air pollution monitoring and climate applications, and being responsible for the startup ecosystem in NIT Kozhikode and in Northern Kerala, the UL Space Club wishes him all the best to produce the best possible results in his work in the days and years ahead. Thank you for this giving opportunity to me.
Thank you very much, sir. Thank you.
Thank you.
Okay. Thank you very much. Can you hear me?
Yes,
Okay.
yes, we can.
Okay. Thank you very much. I'm going to turn my video off and make my presentation in PowerPoint. Okay, very good evening to all dignitaries. I'm very honored to speak in front of you and my dear colleagues and students. So today I would intend to speak about chemistry and physics of climate, not too much about that, much more in a peripheral manner so that our young students in school can learn bits and pieces that may inspire them in future. I would have liked to add some observation or monitoring in the title, which I did not do, particularly because the observation and monitoring of climate is slightly different in my point of view. When we send satellites, they will be looking down on the Earth and will be making a very large view of the Earth and make measurements, where I may be using my instrument in just 1 pixel of that. So I really don't want to give that misinterpretation here. But with that introduction, let me move on to my topic. What is Earth climate system? So this is a very... Oh, slide is not moving? Okay, let me stop presenting and then start present again, yeah? Okay, let me see. It often happens. Maybe I should share the entire screen. Maybe entire screen, if I do the entire screen. And then, yes, then I share the entire screen. It says there is an error. A window. No. Now can you see it? Yes. Ooh. Oh, I don't know. Wait. Let me stop share again. Maybe is it something to do with my internet, do you think? Maybe. Is it okay if I quit and rejoin? Will I have a second?
I think that will be a better option, I think.
Okay, let me quit and rejoin. Give me a second. How about now?
No, sir. But
Really? Can you close me on that account, please?
I left the meeting, correct. You're close to one. Dr. Ravi is totally gone.
No, sir.
So that might be a network issue, I think.
Can you hear me?
Yeah,
Can you hear me?
we can
Yes, sir.
hear you.
It's audible now.
Can you hear me?
We can hear you and see
Yes,
you.
sir.
Can you hear me? No? Can you hear me? Can you hear me?
Yes, we can hear you.
I'm sorry. Just give me one more second. Can you hear me now? You can hear me now? Yes?
Yes, sir.
Yes, sir. Audible, sir.
Okay. Let me try to present again. Sorry about this, but let me try that again. Can you see that now, presentation? Really? You have? I don't know what happens. Give me just 1 second. I will switch to the just give me 1 second, okay? Document. I just switched the computer, just real quick. Sorry about the delay.
No problem.
Just one more try, yeah?
Okay, the last try.
Last try, sorry. I'm really sorry about that.
No, this is you can do. It's a technical issue. What can you do? If it doesn't come, you can speak, talk, and.
Okay.
Yeah, the other option is like, you can share the slides with, say, Shadil sir, and then you can go through the slides.
Yeah, that is a good option, right?
Yeah, Shadil Shah, that's a good idea. Once you share.
Let me see, Shadil. Yes, Shadil UK, Shadil Balisik. Oh, sorry about that. You got it? Yes. It sent. It's actually a little bigger size, maybe because of one or two photographs. Yeah, I have your email ID. Check again.
Oh, that is good. Good. Carry on.
That's good. Sorry about that. I don't know what is happening. Maybe it's my computer. It's a Mac.
Professor Varma, you can start talking. Introduction.
Okay.
Meanwhile, Shradil Marsh will start.
Okay. So I will. Shradil Marsh, can you upload it? Are you able to do that? Yes. Now we can see. Good.
Oh, good. Very good. Very good.
Okay.
Very good.
Thank you very much.
Fine.
And
nice solution. Good solution.
Yes, it's actually good. So you can move to the next slide actually. Okay, so here I sorry I took more than 10 minutes of your time wasted, but I will really quickly go through that. So in the Earth climate system, you can see that the energy is coming from the sun, and there are so many things happening. But anything and everything happening on the surface of the Earth, we have energy coming from the sun, and the atmosphere takes some part of the radiation, and atmosphere contains a lot of chemicals, and that is the chemistry. I will briefly mention one or two items of the chemistry, and then there is water there, vegetation there, soil there, snow, and industry, and clouds, rain, and emission of a lot of particulate matter and chemicals into the atmosphere by the anthropogenic sources. You can go to the next slide. I am not going to read it out or speak about it, but this is something that I took from the courseware of MIT, open courseware. So this is actually there. So as early as 1970, people have realized that the nitrogen and nitrogen oxides of nitrogen have a lot of importance in the atmosphere, and especially related to the ozone in the troposphere as well as in the stratosphere. So from there onwards, three major things. One is NOx, nitrogen oxides of nitrogen, then CFCs that we emit, chlorofluorocarbons, and then also ozone cycle. And then another important chemical is methane and nitrous oxides. Both methane and nitrous oxide are greenhouse gases in addition to carbon dioxide and a little bit of water vapor. But I'm not going to talk about the greenhouse effect here. In this talk, I primarily want to focus on the chemistry part of it. Okay, so can you move to the next slide, please? So here, what is the relevance? So first a little bit of chemistry and then a little bit of physics. So chemistry and physics. So I'll quickly go through it, and at the end, two slides I will devote to the instrumentation that won me the award, and in the process of commercialization. So first, relevance of chemistry. So another depiction of the same. You always are familiar with the IPCC, Intergovernmental Panel for Climate Change. It's a slightly different depiction of the same, which we will see later. So as far as climate is concerned, it's all about the budget in energy. How much we receive from the sun on the top of the atmosphere, at the bottom of the atmosphere. How much Earth is absorbing that radiation, and how much is ultimately given away from the Earth. So Earth as a black body emits in the long wavelength region, which is where the greenhouse effect is coming into the picture. But overall, the change in the radiation budget, total incoming equal to total outgoing, we always are in equilibrium. And when that equilibrium is disturbed, that means that either total incoming is more, or total outgoing is more or less, or vice versa. So that changes the equilibrium position of the climate. So can you move to the next slide? I'll come back to this another depiction later of this later. But I simply wanted to show you something. Ozone cycle. Ozone cycle actually has got a Nobel Prize in chemistry a long time ago, 1997, I think. So if you look at a lot of chemicals, NOxes and methane, or HOXs and CFCs chemistry, the bottom, the last net is saying one thing. Ozone plus oxygen gives, ozone plus oxygen atom will give you 2 oxygen molecules, all of them. So what does it mean? It is destroying the ozone, and the destruction of ozone in the stratosphere is very bad, because ozone is actually going to, ozone is actually produced way up in the atmosphere when a lot of very high frequency, very small wavelength UV, deep UV radiation is hitting the oxygen, and oxygen becomes oxygen atoms, and oxygen atoms become ionized, and one oxygen ion will go to the oxygen molecules, and it creates ozone, and it stays in the stratosphere, which will block the UV radiation from coming and destroying the life below in the troposphere. So stratospheric ozone is, as we all know, that it's a lifesaver, but tropospheric ozone, which comes from the vehicular pollution and oxidation, photo chemical reactions, actually what happens is that they are poisonous gas. But we are mostly worried about the ozone destruction in the stratosphere. So you can see that whatever we emit, once it reaches into the stratospheric regime, then we are really getting into the trouble. So when we talk about chemicals in the atmosphere, we need to see what are the pollutions in the atmosphere, and then just quickly 2 slides I will show how we monitor them optically, because I work on the optics part and the spectroscopy part. So I will just 2 slides. I will simply give you the most or the simplest way of optically monitoring something, pollutants in the ground level. We have other remote sensing techniques to get the. Can you change the slide once? We have different techniques to get the vertical column and vertical averaging and match with the satellite observations and all, but we are not there yet. But if you look at some of the conventional optical instruments, what happens is that if you look at the picture below, there is a light source, whether it is UV or infrared, or maybe a laser like a tunable diode laser, which can scan over one absorption line of the pollutant. And then you put it through a telescope so that you can collimate it and send it several meters to several kilometers, depends on what kind of instrument that you are going to use. You keep a retro-reflecting mirror at the end. We call it retro-reflecting mirror because the light is sent back right into the telescope. If you put a plain mirror, it will never happen, because a small vibration will change the reflection angle and it will never reach back. So small little cubes, 90-degree cubes, small little cubes, like an array is placed, and if you send a light to it, it will bring it right back into the, it'll bring right back into the telescope, and then telescope collects that and send it to a detector. So you can see the light is absorbed or not, decides whether the pollutant or the chemical that you are interested in, whether it is hydrogen sulfide or anything, methane, ammonia, carbon monoxide, carbon dioxide, anything, VTEX, benzene, toluene, and xylene, they are carcinogenic compounds. They are volatile organic compounds, and so all of this, you send the light straight into the atmosphere, bring it back, and see if the pollutants are there. So these are. Can you hit the next again? So it is some text will come in below. So you see, these are all called open path instruments. That means you are not taking the sample, bringing it to the lab and do the spectroscopy. So instead you use, light is sent into the atmosphere, and you call it path integrated optical remote sensing techniques. You can go to the next one. So we did something very recently like that, and using lasers, and this is actually happened in Shanghai too, but this happened a little while ago. You can hit the keyboard again. Shajil, you can hit the keyboard again. So this is two lasers sent. This is a technique that we have not patented it yet. Oh, no, before slide before. Before. Yeah. So this one. So we decided we devised a new technique using a laser. Two lasers having very close wavelength, and we could use some spectroscopic algorithm, and we could retrieve some gases of interest very accurately. And we tried it out for urban pollution, nitrogen dioxide in Shanghai, and we have published that in 2020. So it's a very recent instrument that we did, and we measured it. This is an instrument that we would like to simplify. This is a laboratory instrument, so we actually put it in the laboratory, opened the window, and put a retroreflector almost 650 meters away on the other side of the road, on top of a residential complex, and brought the light back in, and then we did our algorithm. And so this is actually still a laboratory benchtop setup that we eventually would like to translate that into a technology and translate into the industry at some later point of time. This we have not done it yet. So you can take it forward. So before we go any further, I want to show you something here. So this is actually taken from atmospheric and environmental physics, part of the course that I'm teaching. So if you look at the x-axis, it just gives you spatial scale. 1 meter, 10 meter, 100 meter, 1 kilometer, 10 kilometer, like that. It's a logarithmic scale. And if you look at the y-axis, it just gives you the temporal scale. 1 second, 100 seconds, or like that, 1 hour, 1 day, 1 year. It's also logarithmic, up to 100 years. So you look at the chemicals in the atmosphere. You see the bottom two, that is hydroxyl radical, OH, and the next is nitrate radical, NO3. These are radicals, means they don't stay like that in the atmosphere. You cannot put it in a container and bring it to the lab. By the time you do that, it already changed its shape. So these are radicals, and they are the most important oxidants in the atmosphere. OH is happening in the daytime, NO3 only in the nighttime. NO3 will photolyze in the daytime, so you will not find. So they have a lifetime of very, very few seconds. And they don't travel very much. Their spatial scale of roaming around is a few meters. Before that, they will die or change the shape or catch some other molecules and bring it something else. And if you go all the way to the other end, you can see CFCs that we emit, or N2O that we emit. Then it's not just us. N2O is also emitted by other biospheric constituents. So you see that it can travel tens of thousands of kilometers, and it can live there for 100 years. So that means if we emit something out there, it can continuously create or destroy chemicals in the atmosphere and give us a lot of problems. So you can see that this depiction actually gives us the importance of the chemicals, and it is important for us to know the chemistry of these compounds. And I'll simply take one of them, which is nitrate radical NO3. Can you go to the next slide, please? So NO3, you look at NO3. So you see that, NO3 is a very, very small amount you can find in the atmosphere, like a 10 to 50 parts per trillion. One molecule in 1 trillion molecule. That is, you see, 10 to the power of 6 is a million, and 1,000 times of that is a billion, and 1,000 times of that is a trillion. So you see, just 50 out of that can create a lot of trouble. So we can see that 100 or 200 parts per trillion is actually available in urban conditions, and they are responsible for fast oxidation of the atmosphere and then create acid rains and things like that. But they readily die in the daytime, and then that's it. So nighttime, very bad, and daytime they don't survive. So it's important to study the reactions. People are still do not know all the reactions associated with that. But for me, as an physicist and optics person and a spectroscopy person, I would like to make devices that can measure this compounds at very, very, very small amount of present in the atmosphere. Like 50 out of a trillion molecules is not easy to find. Yeah. So can you go to the next one? So earlier we saw that conventional way of open path monitoring was fine. Now we look at a non-conventional design. So we have a non-conventional way of doing things, which can give us a very, very high precision and sensitivity of the instrumentation. I'm talking more in terms of an instrumentation now, like a spectroscopist. You have a broadband light source. You make an optical cavity, more or less like something inside a laser. But inside a laser is different, because here cavity is outside the material, and then you make a CCD array to make a. So I do not worry about the technical terms and jargons, but I will show you the instrument itself. So can you go to the next slide? So how do we study the atmosphere? Basically, we take big Teflon bag. You can already send this into the atmosphere and study what you want, but how do you know if it is correct or not? When you have to make an instrument, you have to calibrate the instrument so that you make a meter stick. You have to make sure that meter stick has exactly 1 meter. So it's a calibration, and you make it into 100 centimeter and like that. So you need to accurately calibrate the instrument so that you can say that you are making a measurement correctly. So in this case, what happens is that in the atmosphere, before you actually take it out into the atmosphere, and some of the instruments that I talk about, it can also fly on an airplane or things like that. Of course, we cannot sample atmosphere from the space unless it is a remote sensing. So we haven't thought about that yet. But anyway, the first thing to do is that you make an atmosphere with a big Teflon bag. You can insert anything and everything you want into it, or you can extract things into it. Can you hit the next button, arrow? So this is a simulation chamber. This is called a simulation chamber. Nothing but a big Teflon bag. And then this is in Germany. So earlier the schematic I showed, we have an instrument. One is in a receiver position, one is in a transmitter position. So light is sent through the chamber. That means it is simulating that light is sent through the atmosphere, and you can hit again. Can you hit it? Yeah. So there is a schematic of the detector side, no, transmitter side, and can you go to the other one? Hit again. Yeah, there is a detector side. Don't worry about that. It's just, again, you don't want to know all the jargons, but you have a transmitter and you have a receiver, and you have some optics in it, and you have a detector in it. One side has a source, the other side has a detector, and light will give you the measurements. Can you hit it again? Move forward. Yeah. So here, just this one, and then I can actually fast forward after this. So if you go here, you see, can you hit that again? So there was nothing in the chamber. The red one is the left axis, green one is the right axis. So can you hit again? So hit the arrow. Okay, so we added 3 ppb of arrow. Yeah, hit it. 3 ppb of NO2. No, something is happening. I'm not seeing it here. So what happens is that you create NO3 in this particular chamber by introducing other pollutants that create NO3. So we simulate the chemical reactions of the atmosphere. And then can you hit it again? What happens? Okay. Okay. Can you go once back? Sorry. I had some issue here seeing that. Okay. So hit forward button. Okay. Okay. Here we finally we take it out of the chamber and place as a transmitter and a receiver unit at seashore to see if ships passing through the channel produces some NO3 that could give us any bad pollutants. You can hit next. So that's the transmitter side. Next. Next. Yeah. So this is actually a harbor where it's a Cork harbor in Ireland. This is actually the last harbor that the Titanic went in. Okay, we'll not go there. Next, hit next button. So that I stopped the chemistry and the chemical what is important in the chemistry, but I think the physics side will be a bit more interesting for you. So let's see, the solar radiation is coming to us as a visible radiation, and it's very easy for us to predict the radiation that we can see at the top of the atmosphere. And you can see the visible light. Planck's radiation law will give us the visible light and exactly how much watts per square meter of energy we'll get in the top of the atmosphere. Can you hit it again? And incidentally, you see that there, visible light is fairly transparent. This is the opacity of the atmosphere. It is fairly transparent, and obviously it has to be transparent, otherwise we cannot see anything. And you can see that there are places where some of the electromagnetic radiation is not going to travel through the atmosphere. Some of them will travel through the atmosphere, for example, like radio waves or for communication band or anything like that. Can you hit it again? Next slide. So if you look at the top of the atmosphere, you see approximately 1370 watts per square meter on the top of the atmosphere. At the sea level, you don't see that much. Some light is missing, and the difference between the top of the yellow line and the difference between with the top of the red line actually gives you the light scattered by the atmosphere. That's what I'm going to concentrate in the next few slides. And then little dips you see there are actually the absorption part of the atmosphere. So light is lost in the atmosphere either by scattering or by absorption. Next slide. So what happens to that 1370 watt per square meter that reach at the top of the atmosphere? So what happens is that about 235 watt per square meter is absorbed by the earth. It heats up and then it's sent out. See, incoming light from the sun has energy in the visible band, and outgoing light from the earth is in the infrared band. So you can see that infrared light is absorbed by the greenhouse gases and it stays like a blanket. So there's a greenhouse effect. So some of the light is absorbed by atmosphere, especially if there are aerosols with the carbonaceous compounds, carbon, black carbon, brown carbon, or if they have carbon in it, it will absorb and it will get heated up. When light is absorbed, physics says that it will get heated up. So that means that that energy stays in the Earth climate system. But if it is reflected back or scattered away, then it doesn't stay in the system. So 1370 watt per square meter has some budget there. Some goes here, some goes there, some goes to Earth, some goes to aerosols, some goes to clouds, some goes back to the space. So there is a budget of processes that has been modeled to do this, and any change in that of one of the processes can upset the climate change parameter. Okay, next slide. So what happens is that what is the effect of this? the effect of this is that we have heating. We have surplus energy absorbed at the equator. We have less energy. I mean, if you take the average, yeah, and if you have a deficit of heat in the polar region. So what happens? Heat, atmosphere and oceans will try to transport heat from the surplus area to the deficit area. So what happens? Atmosphere will, and oceans will work as heat engines. Yeah, they continuously move. They continuously move, and it creates our weather patterns and patterns of the climate. So weather is the day-to-day matter, and climate is like a long-term averaged pattern of the movements. Okay, we can always say that at this particular season, wind will come from southwest, and some other particular monsoon retreat wind will come from the northeast. So that kind of things are climate. But today the wind is coming from the south. That's the weather. So this particular process, differential heating of the Earth climate system, is actually responsible for the large-scale movement of the air and water, which will create the things moving, or everything is trying to manage to the average. Can you hit the next slide? So look at that. What is the first effect that we are going to see? You see, there are two jet streams. Those who do flying, those who do flying from here to London, or I mean Delhi to London, or Delhi to San Francisco, you see that 10 kilometers, about 10 to 17 or kilometers above the surface, there is a jet stream. There's a pipe like strong winds. You can see about 120 miles per hour or 140 miles per hour at the core. There are two, subtropical and polar. There are two streams. So what happens? This is a very, very strong flow of air, like a tube. So when someone is trying to fly from Delhi to London, what happens? You are flying against the wind. You have to spend more fuel, and you spend more time to reach London. When you fly from Delhi to Tokyo, what happens? You are going with the wind, or you are coming from London back to Delhi, you are flowing with the wind. So wind carries you, plus your own motion, so you spend less fuel. And also, in fact, Air India has a round world flight from Delhi to San Francisco. It flies over the Pacific to San Francisco and comes back over the Atlantic to India. So this is flowing with the jet, so it can save a lot of fuels. So this is jet stream, is an atmospheric circulation. And jet stream is happening because of the differential heating between the equator and the pole, and the rotation of the Earth. I may speak about it in the next slide or later, but may not be also. So can you go to the next one? So this is not the only thing that we see. We can see vertical overturning of the air. That means what happens is that Earth gets heated up, or the ocean gets heated up, let's say. So it starts evaporating, and moist air is lighter than the dry air, so air starts rising. You can see it rises away, and then it goes up in the atmosphere. What happens? It condenses. And then what happens? It rains. So the heat, latent heat of evaporation is taken from the sea surface. Latent heat of condensation is released in the top. So what happens? Atmosphere is trying to transport the heat from one place to another, and then air has to come back somehow. So it's not going to sink right there. It's going to flow both ways towards the polar regions. See, that's what happens. So air rises, goes to the polar region, and somewhere there it sinks. So there, where it sinks, you see, angular momentum is picked up from the surface near equator, and it is dropped at some point where it starts sinking. That is continuously kicking the air, which is actually the conservation of angular momentum is actually responsible for this jet stream also. So you can see the principle of physics is working very nicely. But then there are equations, and sines and cos will appear, and if I go to the equation, and then you'll see that somewhere it will break down. So this particular jet streams cannot go all the way to the north to the pole, it cannot go all the way south. So there is a balance always, and the differential heating, climate change is all upsetting this. So can you go to the next one? I'll just quickly show you one big picture where all the kind of patterns you see happening due to the rotation of the Earth, as well as the differential heating between the equator and the pole. So that is actually giving a lot of circulation in the atmosphere, and people are studying this and trying to model it and trying to predict what happens to these circulations. Will they weaken, or will they stop, or things like that. So I will quickly go to the ocean circulation, and then we'll stop from there. I will not go further into the other part. Yeah, can you move forward? So this is taken from National Geographic, it's actually there. So something called the Thermo Haline circulation, or ocean conveyor belt. What happens? Surface of the ocean will get heated up, is warmer, and so what happens is that there is a flow is created. It starts flowing from one place to other, and at some point of time it radiates and it cools. And then what happens? It sinks there. So at some point of time, at some place underneath, water gets heated up, then it will rise. The density varies. So this actually is also another process of transporting heat from the equator to the pole. Can you go to the next slide, please? So look at that. The red ones are all shallow warm current, and blue ones are all under the ocean, deep cold current. So students, if you have seen the movie Finding Nemo, somewhere there it says that, look, Australia is there, this is a highway, they're talking about the Great Australian Current. That's that shallow warm current. Yeah, so that's there. So it goes round and round and round, and it takes probably 1,000 years to complete one parcel, starting from one place to the other. So the global conveyor belt in the ocean also is responsible for part of the heat transport from from equator to pole. Can you give the next slide, please? So if you look at that's about some part of the chemistry and some part of the climate, that energy input and energy working as a circulations of the atmosphere and this thing. Just quickly, if you look at the last column, that is the level of scientific understanding. We know very well about the greenhouse gases and everything. We have very high understanding. But if you keep going below, immediately you see that aerosols, or the particulate matter in the atmosphere, our understanding is quite poor. We do not know what exactly they are going to do to our climate. Primarily, what they are going to do to the light received from the sun. We do not have a good understanding of that. So that's where I focus my research on, and I will briefly, just quickly tell what is something that is interesting, maybe interesting to you. Next slide. So here I'm talking about the light scattering. Light will come, it will hit the particle, it scatters. Going forward is forward scattering, going backward is backward scattering, going at any other angle is angle scattering. So it's called the phase function. If you measure the light around it and you normalize it, then you will see it's called phase function. Next slide, please. So we have elastic scattering, inelastic scattering, and quasi-elastic scattering. Inelastic scattering is Raman scattering. Raman effect is there, and elastic scattering is what we always worry about. It's just scatters without changing the wavelength, without changing the energy. So we know that why sky is blue is because of the Rayleigh scattering, and why sunset is on the horizon is red. Again, it's a scattering, but a more general theory called Mie scattering. Rayleigh scattering is one end of the Mie scattering. Okay, go forward. So scattering, light is scattering. Light scattering has something to do with the wavelength and the size of the particle. If the wavelength is visible light, if the particle is a molecule, then incoming light is 400 nanometer. Particle size is a few angstrom to low nanometer. Then the light wavelength incident is very high. very large compared to the size of the particle that scatters, and there you go, that is Rayleigh scattering. But when the particles gets bigger and bigger and bigger, like the aerosols in the atmosphere or the cloud droplet in the atmosphere, suddenly it goes away from the Rayleigh scattering, it becomes Mie scattering. And then you keep increasing the size of the particles to bigger and bigger, to several micrometers, to millimeters, then suddenly we get all the results that we are familiar with. Loss of reflection, the loss of diffraction, I don't know, whatever. That is the geometrical optics. So Mie theory of light scattering is a general theory. One end goes to the Rayleigh scattering limit, other end goes to our very familiar geometrical optics also. So next slide, please. So you can see that when light is light wavelength is large, particle is small, that is Rayleigh scattering. The first one is like that. Light scatters pretty much every direction. When the particles start growing or bigger and bigger particles, what happens is that with respect to the visible wavelength, what happens, a lot of light goes into the forward direction and a little here and there. So that is the Mie scattering phase functions. You see the light scattered in different direction takes different this thing. So go to the next slide. So you can see that Rayleigh scattering by the molecules, if you look up and sun is in the horizon, you can see that it is blue. It's not the same when sun is up. Okay. Now when you look at the horizon, that's the particles doing the Mie scattering. So it's all the same theory, but to end of the spectrum. It's also matter to the brightness of the sky. But I don't want to stop in the next slide. Go 2 slides forward. One more. There you go. Oh, no, before that. Okay, you see. So in the theory, I'm not going to give you any theory, any electromagnetic theory or scattering theory or anything like that. Let's forget about that. But you look at the size parameter. Size parameter 1 means particle diameter is same as the wavelength incident. Size parameter 5 means light size, particle size is much bigger than the incoming wavelength. And what we calculate here is the efficiency of scattering. You see, it's like a wiggling thing. It looks to us and it doesn't make much of a sense or anything like that. You will think like that, but actually makes a lot of sense. That's what I'm going to tell you in the next slide. The physics can explain some of the phenomena. Next slide, please. Look at that. What you see here is a paper from my research supervisor from the data that we obtained from the rover in the Mars. Look at that. This is a sunrise or sunset. I'm not sure it's a sunrise, probably. Doesn't matter. Look at the horizon. You see blue sun. What are we familiar here with? We are familiar with red in the horizon. So why we should be seeing blue? Can you go to the next slide? So I simply take that scattering efficiency curve, and you see, if the particle sizes are uniform, you have the same size of the particle in the atmosphere. We never have that. We have all sizes of particles in the atmosphere. But maybe at some point of time, if we find all same size of the particles, what happens? On one side of the peak, it becomes reddening, and the other side of the peak, it becomes bluing. That means left side means all the blue, the maximum scattering efficiency in the blue part of the wavelength, and the less scattering happens in the red part of the wavelength. And that's what we see the sunset in Earth. But on the other side, you see blue scatters less and red scatters more. So what happens? You see a bluish effect in the atmosphere. So you see, it's very simple to explain. Physics can explain this phenomena that observe in the atmosphere. Can you go one more? Here you can see this is part of the theory. I don't want to explain too much. You can see that theory can tell you sometimes green. You can see green. Green has the least. If the R is just 1 micrometer, then green you can see greenish. It's actually available, but I didn't put there. So next slide, I will probably my last slide about the science part. Once in a blue moon, you look at the trees. sometimes the trees will perspire some terpenes, some volatile organic compounds, or some, they all condense into small, tiny aerosols. So they are all uniformly emitted, uniformly grown into aerosols. So what happens? There is chance that pretty much all of them will have the same size. And, see, that may be in the bluing side of the efficiency spectrum. So it is possible that very, very, very rare conditions, but you can actually see blue moon and blue ridge mountains. It's like the bluishness of that is more often, but once in a blue moon also has something to do with the bluing because of the specific distribution of particles in the atmosphere. So next slide, please. Now I come back to the thing that I get honored. You see, I had a project from Kerala State Science, Technology and Environment. They gave us some money to build an instrument that measures broad spectrum scattering alone. You see, it's not easy to measure scattering alone. It's not easy to measure absorption alone in a broad spectrum. Okay, it's very, very difficult, believe me. It is easy to measure the total light lost. But total light lost due to scattering and total light lost due to absorption are important, so that absorbed contributes to the Earth system climate, Earth climate system, and as temperature, light lost due to scattering gone out of the system. So it has a lot of implications in the climate studies. So we in 2018, 2016 we got the project and we had a handwritten diagram to begin with, and now we have AutoCAD, CAD-based diagrams and this thing. Then we, from handwritten, we made some preliminary experiments, fabricated an instrument in the lab. In 2019, we got a chance to take it to the field in China. We took it to China not because we don't have aerosols here and the pollution there in China. It is because they had other instruments where we could compare our measurements with. And then we came back, and 2020 we made a perfect design onboard computer and stuff like that. And like every instrument, we also did the, can you go to the next slide? We also did the calibration by measuring the Rayleigh scattering of small particles that are gases. And we did the measurements and we published a paper and we patented it, and now it is being commercialized. Can you go to the next slide? It's being commercialized and we have a nice looking instrument at the moment. We have a prototype. KSTEC, Kerala State Science, Technology and Environment has given us permission to transfer, and we transferred it to Optint Solutions, which is also a spin-off company from my lab. We have other spectroscopic innovation, but this is something that is, we are projecting it as a climate tech instrument. Direct monitoring of a climate parameter. That's what we are up to. Go to the next slide. With this, I know I really ran through it. I couldn't explain too much things because of my, as far as climate is concerned, some chemistry, some physics, and some inspiration. That's my hope. Thank you very much.
Thanks, Sajil Mash. Already time is too late and students are waiting. And we have had two excellent presentations. And I am very, very thankful to Dr. Ravi Varma for giving an excellent science talk, which students are to listen and have enjoyed it. I'm very, very sure. And the project is very, very good. Now, I think we'll request Niyati to come, isn't it, Sajil Mash? Okay. Okay. Okay.
Hello, sir.
Yes, Niyati.
Let me start the presentation. Can you see the screen?
Yeah, we are.
Greetings to one and all present here. We three, myself, Niti Tashin Karat, and my friends Sri Lakshmi and Lavanya, the members of the team Sun Center, are here to present our project. Let us analyze radiation from sun. We are 9th standard students of JHSS Nanavanu. First of all, we express our gratitude towards UL Space Club for giving us such a golden opportunity to present our project in front of you all in the National Science Day itself. Thank you. And we express our special thanks to our members, Sri Chindan Kuti Nambiasa, and our teacher guide, Srimati Sharmini teacher, and our beloved parents. And before going to the deep explanation of the presentation, I would like to give a small introduction. Our project intends to study about sun and the activities on the sun surface by analyzing the ionospheric disturbances created by solar radiation. And here we are not really analyzing the solar radiation directly. The solar radiations which is reaching the ionosphere is bouncing back from there. And that solar radiations which reaches the ionosphere creates ionospheric disturbances. We are monitoring it through VLF stations. There are a lot of VLF stations in the world. They are transmitting VLF signals, very low frequency signals, to the ionosphere. And when it reaches there, it will be bounced back. And these bounce back signals are received through antennas. And there will be difference in the frequency of the transmitted VLF signal and the received VLF signal. We are comparing them to, and by analyzing the difference, we will be able to understand the differences happening on the ionosphere and on the sun surface. And there is a VLF station in India. It's in Tamil Nadu, and it's in Vijayanagara, its place, and it's known as INS Kattabomman. The frequency of the VLF signals, which is transmitted from there, is 18.2 kilohertz. And when starting the project presentation, I would like to start with space weather. The activities on the surface of the sun create space weather. And some conditions on the space have the potential to affect us on Earth. Such conditions are known as space weather. Some such conditions are given in the screen. They are solar flare, solar storm, coronal mass ejection, etc. These can affect the Earth in a very well manner. The solar storm damage satellites and it affect animal movements, and also it disrupt the power distribution. And also a chance for is that it may be a threat to the high flying aeroplanes and the astronauts also. It's also a very good chance. And we have already seen the ionospheric disturbances and those things. And here we are looking what is ionosphere. It is located 60 kilometers above us, and there every atoms are situated in an ionized state. Due to the blast of sun, the new electrons are stripped out of the nuclei, and the electrons and nuclei can be seen separately in the ionosphere. These free electrons in the ionosphere play a major role in the propagation of radio signals. It helps us to communicate very well through this radio communication. What is happening there is that when we are transmitting a signal through our gadget, it will reach the ionosphere and it will be bounced back. And using this signal, we can communicate all over the Earth, all over our curved Earth, and over the horizon also. And we are looking about what is Vlf transmission and how it is possible. That we need an antenna or a radio receiver to tune to very low frequency radio stations. And a normal radio cannot pick up these very low frequency signals. So we need a separate receiver for it. And we need an antenna to pick up these signals and a computer to track the data of these things. And also we need around antenna and receiver to do this project. And the combined system of this antenna and receiver are known as Srd Monitor or Sudden Ionospheric Disturbances Monitor. And you can see the pictures of the signal receiver here. And in the signal receiver, a certain frequency is arranged so that it will only receive the signals or radiations of that frequency. And one important thing is that this frequency won't be same everywhere on Earth. It is based on, or it is arranged based on the frequency of the VLS signals transmitted from our nearby VLS stations. So it differs from station to station. And another interesting fact is that the US Navy uses this very low frequency rays to communicate with its submarines. And they have a lot of transmitters scattered around the world. And the distance between the two submarines or the center and submarine is not a problem for them. And they could easily communicate to the submarines by sending a signal, and by it will be bounced back from the ionosphere, and anyone could pick it from everywhere. And that's an important property of this VLF radiations. And another important study which we saw is that it was an interesting study also. It was done by Mr. E.R. Moganshi of Pavia University. He saw that, or he observed that we would predict the earthquakes by analyzing these very low frequency signals. It's an interesting fact which we saw during the study. And before getting more deep to the presentation or to the project presentation, we need to familiarize ourselves with some terms. First one is solar flare. As we all know, it's a sudden flash of sun, especially near the sunspot. The second one is solar storm. It's a temporary disturbance which forms on the Earth's magnetic field due to the solar radiation and the charged particles from the sun. The next one is coronal mass ejection. This coronal mass ejection is happening because the magnetic field, accompanied magnetic field of the sun, moves from its sun's corona to solar wind along with the plasma. And we could see a video of this coronal mass ejection. You can see that. And we can see again with Earth to scale how much big is that phenomena. This video shows how big is that coronal mass ejection. And we would like to tell more about which are the ways we use to study about these things. That we could use optical astronomy and radio astronomy to learn about this project. We have used radio astronomy, which studies celestial bodies at radio frequencies. And the next option is that to select whether radio telescope or select monitors like Srd monitors. We have selected the Srd monitor here because the radio telescope is very expensive, and also we will get accurate results from Srd monitors too. And from this first part of our project, I think that we all have understood that these radiations affect us and the climate of the Earth and many other factors in Earth very well. So it's very important to study about these radiations and the sun's surface, the solar activities, the ionosphere, ionospheric disturbances, etc. So for it, we must need such a monitor. And as a next step, group member Sri Lakshmi is going to tell you about how we constructed the Srd monitor and how we assembled it and such things related to the Srd monitor. I welcome Sri Lakshmi to present it before you, and thank you. Good evening all. My name is Sri Lakshmi. This is the Srd monitor made by us, consists of an antenna, amplifier and a monitor. This system functions for analyzing the Vlf signals. This function for the Srd antenna is to receive Vlf signals. This antenna is called wire loop antenna. It has a very simple structure and there is nothing other than a frame that holds wraps and loops of wire. There is no fixed shape or size for the antenna. We can build the antenna with less than 1 meter width or more than 2 meter width. The larger antennas are more sensitive but difficult to carry. Smaller antennas are very easy to build, but it requires more wires to pick up the signals and are not sensitive as the larger antennas. The larger in diameter, the better your antenna will be. 25 turns on a 2 meter frame is better than 50 turns on a 1 meter frame. This antenna is inexpensive so that it can be made of rosed broomsticks and spare woods. Anything that is non-metals and conductors fine. While constructing the antenna, if anyone faces any difficulties, they can read the directions and designs by Stanford University. The Vlf signals will be very weak, so it cannot be converted to digital signals. To amplify this, we are using an amplifier developed by Stanford University. This amplifier is known as Srd receiver. And we need a monitor to analyze the signals. You will be able to understand how much weak the Vlf signals when we compare to something we know. The frequency of Vlf signals is 21.8 Hz, whereas the frequency of Akashvani Calicut radio station is 10 crore 36 lakh Hz. The wavelength of this Vlf signals is between 0.1 and 0.8 nanometer. You can see the ranking of solar flares based on the X-ray outputs in the screen. Flares are classified according to the magnitude of peak burst intensity. It is represented as I. Now you can see the original and super Srd monitors in the screen. Both are doing almost same function, but the second one is inexpensive and convenient. Now let's look how to combine the Srd monitors. First, connect the antenna with the amplifier using coax cable. Then connect the amplifier with the computer. If we open any audio recording applications in the computer, we could hear the sound of the radiation. Let's hear it. I think you heard the sound. The next step is to analyze the digital signals. We have done this analyzation using Python programming language. Our team member Lavanya is going to present the ideas about it. I welcome Lavanya and thank you. Good evening. My name is Lavanya. By using the software designed by the Solar Center of Stanford University, we converted the radiations into digital signals. The software records the solar radiation. The software records the solar radiation in the form of the software records solar radiation in the interval of 5 seconds. While converting to digital signals, there will be a number representing the frequency of radiation along with the time. By using that data and writing suitable program, we will be able to convert those data to graph regarding the variations of radiation in that day. If we club the data of 2 days, we will get a graph which consists the radiation frequency of that day. Acquiring data about solar radiations can be done in 2 ways. The first way is to use the digital signals which the antennas capture. The another method is to download the data from the repository of Solar Center. The advantage of this method is that a person who can't install antenna can also analyze the radiation. We have gone through both of these methods, and after taking data from software and repository, we have made the graph with Python programming. We have made the graph with some random methodologies like radiation in 2 days, radiation-based weather, radiation in day and night, radiation in first day of each month. You can see the graphs and peaks of last 2 days in the screen. All of them are not because of solar flare, but some are. Like we said in the beginning, it's just a first step for us, and we are excited to study further about it. As a starting, we start a repository to collect and store data daily at our school. We would like to study further about monitor, amplifier, antenna, software, etc. We expressing gratitude to each and everyone for listening to us, and special gratitude for UL Space Club to give us an opportunity to present before all of you. Thank you for supporting us. Thank you.
An excellent presentation, dear Niyati, dear Lavanya, and dear Sri Lakshmi. When I met you yesterday in your school, I knew that you are ready for the presentation, but the style of your presentation, that confidence with which you presented, and your entire style is something so exciting for us, and we are very proud of you. We are very, very proud of you. I leave the next to Dr. Nikhil Vogel to comment and proceed with the program. Thank you.
Hi, can you hear me?
Oh, yeah. Oh, yes, we can.
Very well.
Okay, so yeah, first of all, thanks to YV and KrishnaMurthy sir, and Varma sir and the students, Lavanya, Srilashmi, and Niyati for their excellent talks. Niyati, yeah, for her excellent talk. And when I was listening to Varma sir's talk, it was like I was sitting in his class almost 10 years back because I took the same course, atmospheric and environmental physics course. So it was very nice to listen to him again. And personally, he has been an inspiration to me to take a career in experimental physics, and he has always supported me. And so it's very nice to see him. And one thing that I wanted to say was like, he showed an example where you can actually build. You don't have to import an equipment from outside India. He has shown us that we can build something in India and then get very nice results and even export it to other places. So that's a very nice thing that students can follow. And even KrishnaMurthy sir, also it was very nice to see him talk about the SS space and the Inspire Sat that they are building at IIST. And I personally think it would be nice if we can connect IIST and NIT Calicut so that we can have some sort of collaboration between both the institutes, because we also have an engineering physics department at Calicut, so that might be mutually beneficial. And finally, the students, I was like surprised by the content of the talk. It's very high quality stuff, and and they have shown that even with such equipment, and it's possible to measure something like you can actually do radio astronomy with such equipments, and it was impressive that they could assemble it and then collect data and then even use Python and analyze it. So I wish them all the success, and I would like to point them that they should check GMRT. So it's called the Giant Meter Radio Telescope. It's in Pune, and it's one of the world's largest and most sensitive radio telescopes. And we have one such equipment in India. So you can go and check the stuff, and they have routinely like workshops and all, so you might benefit. I can also put you in touch with some of the members there. That's it. So thanks again for organizing, and then I will hand it to the next person.
Well, it's been a long day. I don't want to take too much of a time, but there cannot be a better way to celebrate that National Science Day than what the UL Club has done it, as usual. Getting a good variety, best of the speakers, Dr. Ravi and KrishnaMurthy, Ravi Varma. And more importantly, I wanted to make a very specific comment about the way the three girls spoke. The content as well as the presentation was so authoritative. Very happy, because on one hand we are all thinking, okay, now the children of today, are they really interested in doing this kind of stuff and things like that? No, there is one pessimism like that. With COVID condition, they have got break in their studies, and would they even know what is the quadratic equation? They may forget, and that kind of stuff. Whereas what these girls did, the kind of presentation showed that, it was absolutely fantastic, because I was just remembering my 9th standard days. I would never have probably done anywhere near this. So we will support them very, very well. And by the way, the UL Club is always very good in getting the right people. One of the ex-directors of GMRT, Dr. Rajaram Nityananda, has spoken on the radio astronomy to this group. And some of these girls might have also probably listened, or we can play it back. And I think that we have got enough connections, and we will try to introduce them. But more importantly, science is very much alive, be it in IIST and then collaborating with world over, or with the basic science which has been there right from time immemorial of studying the atmosphere and deriving the science out of that, as well as with the younger people getting interested in some activities like this. Whatever that does will create a very good ripple, and I'm sure that is what is our purpose, and we will support all of them. Thank you very much for a wonderful evening. Bye.
N. Sundarajan.
Yeah. Yeah. Can you see me? Okay, I'll put my. Yeah, I'll put on the camera.
Now we can see you.
Okay. First of all, I have a couple of comments mainly. The whole thing was very good, enjoyable. It's very late here, but I'm still awake because of course, I really wanted to listen to the students. And very interesting presentation. I'm surprised they are doing at this age this kind of experiments and all, right? Even they're talking about antennas and all. So very, very interesting. I think the club is doing the right job, putting in the seeds in the minds early, so that when they become this thing, it will grow into a full scientist form. And only I have a couple of suggestions to all the three, Lavanya and Niyati and the other gang. Okay, on the presentation. First of all, I didn't understand what is VLF for a long time. See, because you are all familiar, you are working in that area, you know it. So don't use acronyms if you can. VLF means very low frequency, right? Yeah, you have to say that upfront. Okay? I was thinking of whatever, something else. So don't, especially for students, right? So make it very clear, VLF is this. Then within bracket, you can put VLF and use it further. First time you use it, you have to say that. That is one. Second, you are putting a lot of figures, graphs, right? If she can show it, I will ask that question, but I don't know, it will go time. I want to know what is x-axis, what is y-axis. You put some numbers. Never present a figure like that, you will be torn. What is x-axis? You said time. But time in what? In seconds, minutes, or milliseconds? And you said y-axis is what? Frequency, right? Something like that you said, right? It is the hertz or minute. Never present a figure without the units. So this is a very, very important, because you are all young students, right? You can't just put one figure, some curve with some numbers in X and some numbers in Y without telling what it is. Never do that. Okay, that's all for the correction, because I am a professor. I always find faults in students' presentation. And I have a very name that I am very nasty. But I'm nasty so that you improve. And when you go and present outside, it will be very clear. And one question for Professor KrishnaMurthy I have. It's very nice, very interesting to see that you have a lot of international collaboration for building satellite and all. So, except that scientific payloads and all, apart from that, you should be looking at some technology payloads also. I will give a simple example. You can put students into thinking along these lines and build up something. Refueling satellites, correct? Now we put a satellite into orbit. After some times, the lifetime is gone because every electronic system, everything is working, but there is no fuel in that. So now whenever our car runs into a problem, we go to a gas station. So why don't you think of some attempts in like robotic thing. So somebody carries a fuel and then we go and connect it to the satellite tank and fill it up. So not only science, I'm not saying only you should be doing that, but put your students in the other way also. Some or repair. Some electronic bags in your satellite has gone off. Okay? So you can save a lot of cost on that. Of course, it has to be in space. So you have to develop a mechanism for that and all. Think out of the box thinking, which ISRO cannot do in the normal because they're busy with all their projects and all. So when I was suggesting this thing, they threw me out. Go and do research in So IIST is the right place to do this research. That's all I want to say. I really enjoyed. Thank you very much.
Thank you so much, Dr. Rangarajan. Nasty Dr. Rangarajan is such a pleasant boss for our students. They can approach him, call him, talk to him any time of the day. Right now, he has given up his sleep. It is midnight there in Singapore. And 2.5 hours ahead of us. So still, he's alive and with us and with our students. So nice of you, sir. Thank you so much. Thank you. Few words, sir. Few words.
As an instrumentation person, I see that such attempts from very young girls, it's very, I'm very happy to see that. I'm thrilled to see that, this is all electromagnetic radiation, the detection of that, and interpretation of the data. So that it takes a lot of knowledge and work behind the, to understand what is going on. Just taking at some signal at your detector, you are interpreting something happening way out there. That's very important. And I think they have done a wonderful job, and they are knowledgeable. They are truly, inspirational for their fellow students, I hope. Very well done, girls.
Shajirma shared to go to the ground station for something related to the satellite. He just told me and went off. No, I think if anybody else here wants to say something, they are welcome. I think we will not worry about this 9 or 9 past thing. If anybody wants to say something, students or any student.
I think some of them raised their hands.
Why did you come out? Why didn't you come out? Please come forward. Please come. If nobody is there, then you can go for word of thanks.
Shil sir, can I invite one person?
Sure.
Goguleta, can you please speak up?
Please.
Hi, I'm Gogi Krishna from NSS College of Engineering, currently pursuing BTech degree, 4th year. And at our college, we are also planning to do a satellite payload project, just as IST did on like AIRS type by utilizing the PS4 opportunity which put forward by ISRO, and it's actually at the initial stage, planning stage. So if KrishnaMurthy sir is here, I want to ask out to him. Is he available now? I think it's not.
No, yes, he is not available right now.
Okay, it's fine. After all, it's a great opportunity to have to hear a great talk on this memorable day, and that's all. That's all from my side. Thank you.
If you have any doubts to raise to KrishnaMurthy, you can talk to Varun. Varun has an access to him. Varun has an access to him, or anyone of us. Thank you.
Thank you so much. Thank you so much, sir.
Hi, good afternoon, everybody. On behalf of ULCCS Foundation, first of all, I thank all the persons joined in this program. As we all know, National Science Day is celebrated on February 28 to commemorate the discovery of the Raman effect by one of the renowned physicists, C.V. Raman, on 28 February 1928. This day is celebrated with an objective to bring awareness among people about the significance of science and research in day-to-day life. On this auspicious day, scientists, experts, and eminent scholars address people through various medias to discuss relevant technologies, research, and trending achievements. This will motivate, inspire, and ignite the curious minds of young innovators, scientists, and students. And this celebration will help to develop scientific temper in our society and to better their life. If you believe in science, you would always be logical in all decisions. On this auspicious day, we have two eminent persons to deliver speech on science and technology of Inspire Srd Mon program by Dr. V.V.N. KrishnaMurthy, and Science Behind Global Warming and Technology of it by Dr. Ravi Varma, MK. Dr. V.V.N. KrishnaMurthy is already a part of US Space Club, made a brilliant speech on Inspire One program, and it brought a lot of information. We are grateful to you for joining us and the Lukeland speech and for honoring Dr. MK Ravi Varma for his great achievements. I extend our sincere gratitude to Dr. V.V.N. KrishnaMurthy. Thank you, sir. Dr. M.K. Ravi Varma has made a brilliant presentation about the science of global warming and upper atmosphere, also about the basis of Raman effect. The speech was very informative, and I think students gained a lot of knowledge. I am proud to thank Dr. M.K. Ravi Varma and congratulate for his great achievements. Varma sir, I also thank once more. Niyati Darshan, Sri Lakshmi, and Lavanya made a very excellent presentation about solar radiations. You have done a good job. We are very happy to thank you kids. I must thank all the veterans like P.J. Bhatt sir, Padmanabhan sir, Rangarajan sir, and Sundaramurthy sir, and young scientist Nikhil Vogel. Heartful thanks to all. I thank all the students and parents joined in this program. I also thank Sri K. Kuti sir, Sri Shejil Master, Master Varun, and all the others work behind to make this program a success. Once more, I thank you all. Thanks.
ഞങ്ങളുടെ ഇന്ന് ആര്യ വന്നില്ല നമ്മുടെ പ്രോഗ്രാമിന്.
Bye.
നാഷണൽ സയൻസ് ഡേ പ്രോഗ്രാം കൺക്ലൂഡ് ചെയ്യാൻ പോവാണ് ഇപ്പൊ. എങ്ങനെ അറിയാതിരിക്കുക?